Who stole the money? So in this video, our objective is to find out who is stealing the money in this small business. So here we've got an attendance register. On the left we've got the different business days. Next to that we've got an amount which represents the shortages or overages on the various business days. And then to the right of that we've got a list of employees and their attendance or absence. Attendance represented by a 1 and their absence on the various days represented by a 0. So based on the attendance correlated with the various shortages or overages on the days, we can determine who is most likely to be responsible for the shortages. So to do this, we'll do a regression analysis. Go to the Data tab, Data Analysis Toolpack, which can be found in the Excel options as an add-in. So the goal here is less to demonstrate how to do this analysis, but just more to showcase the usefulness and the applicability of an analysis like this, even a very simple regression such as this one. Even though this is a multiple regression, it's still a very simple application. So your y input is your independent variable, and here we've got our employees as the y input is the dependent, employees as the independent variables. Okay. So here we've got the regression output. I've just added a few descriptions next to some of the values which you can have a look at if you'd like, but I'm just going to go through the important ones. So up here we've got the fit, how well our variables are correlated. We've got multiple r squared, and your adjusted r squared, which would, the adjusted r squared just compensates for the sample size. The most important value we want to look at is down here. The first thing we look at are the coefficients. So on the left we've got each of the employees, and next to that, under the column coefficients, what this number represents is the amount of dollars on average that each employee contributed to the business. So on average, Peter contributed $7, on average Sarah contributed negatively with $23, and so on. The next important value is the p-value, and it's a percentage. What this represents is the probability that the coefficient occurred randomly. So there's a 34% chance that this figure just happened by chance. You can see all the figures are relatively large, and then we've got one very small number. Lower and upper 95% refers to the upper and lower confidence bounds. So with any statistical analysis, there's bound to be some error. So what these two numbers represent are the boundaries for that error. So how you would read this is, we are 95% certain, given that there's bound to be some error in the analysis, we are 95% certain that the coefficient lies between -8 and +22. So that's how you would interpret those two figures. So if we have a look at the coefficients, immediately Sarah pops out because she's got a -$23 impact. We have some other people with negative values, -7, -5. But first we'd like to look at Sarah. Now from the coefficient we go to the p-value, and Sarah's p-value is 1%, which is quite significant, meaning that there's a 1% chance that this happened by accident, meaning there's a 99% chance that the coefficient is very accurate. Even so, even taking error into account, we can be 95% certain that Sarah, in the worst case, contributed -41, And in the best case, being 95% certain, she still contributed negatively at a -5. Another significant observation is that everyone else's upper bound is positive, while Sarah's upper bound is the only one which is negative still. So even in the best case, Sarah is still contributing negatively. This would give us a very good idea that Sarah is most likely the one that's responsible. So what do we do about these other negative values then? Well, we can narrow it down, which I've done here. We can narrow it down to only the negative values, and when we take that into account, we see two of them come up positive. So because we've narrowed it down, we've now eliminated another two names. Linda and Lily actually contributed positively on average, now that we've narrowed down the data. And when we narrow it down again, we see that Sarah is still standing out like a sore thumb. The p-value is so small that there's basically a 0% chance or 0.5% chance that she's 0.4% chance that this number is random. Still, she's the only one with a negative upper bound. So what about, so we've basically determined that Sarah is the one that's responsible for stealing, most likely. So what about these other guys that are contributing negatively? Well, as in any business, employees make mistakes. They give out the wrong amount of change. Customers accept the wrong amount of change. Things like that contributes towards these types of mistakes. But statistically, Sarah is the one that is most likely to be stealing the money. So with an analysis like this, we certainly can't have the police arrest Sarah. But what we can do is say, we've got a much better idea of what the situation in the company is now. Now we can take steps to either monitor Sarah or speak to her so that we can determine what the best next step is. Without this type of analysis, we would be completely in the dark, and finding the culprit for all the shortages might have been a much more difficult task. So I'm sure you'd agree that a regression analysis like this is extremely useful for a business.